Welcome back to part 2 of Trig 1.6 or Pre-Calc 4.6 video. The concept for this portion of the video is graphing the cotangent graph. So if we look at some of the basic qualifications for the cotangent graph, we'll notice that they're very, very similar to the tangent graph in the fact that the amplitude is still A, the phase shift is C over B. And you can see that there's my cursor is there, but that does say C over B. The period is pi over B, just like it was for the tangent graph. And the vertical shift is D. What will change, though, is how we find our vertical asymptotes. With tangent, we were setting them equal to pi over 2 and negative pi over 2. Well, with cotangent, they're equal to 0 and pi. So we take our bx minus c, we set it equal to 0, and we set it equal to pi. So that's a big difference in terms of finding the vertical asymptotes, how the cotangent and tangent graphs are different. The other difference is when you actually draw the graph is going to look like this, where the left side is rising and the right side is falling. So left side is going up, right side is going down. And again, that's important to keep in mind too when you graph it. So we'll find all of the characteristics, we'll put our vertical asymptotes on, and then we'll make our graph go right through the middle of the vertical asymptotes. So our amplitude, period, phase shift, and vertical shift. Our vertical asymptotes, bx minus c is equal to 0, and bx minus c is equal to pi. So if we go through and plug that in now, looking at this, if we identify our A, B, C, and D, our A is an imaginary 1, our B is an imaginary 1 also in front of the x, and we don't have a C or a D. So if we think about this, absolute value of 1 is 1. The period is pi over 1, which is just pi. The phase shift would be 0 over 1, which is just 0 because there is no C, and there is no vertical shift. When I put my asymptotes on the graph, my bx minus c for this graph is just an x. So x would be equal to 0, and x would be equal to pi. So we'd have 0 and pi would be my asymptotes. So at 0 we draw an asymptote, at pi we draw an asymptote, and then we find the halfway point between 0 and pi. The halfway point would be pi over 2. So we put our dot in the middle here, and we make the left side rise, and the right side fall. And so my graph is going to look like that. Putting another period on here, we would want to add whatever our period is, pi. So if I do pi plus pi, I get 2 pi. Draw the asymptote. The halfway point between 1 and 2 would be 1 1/2, or as an improper fraction, 3/2. And we make the left side rise, the right side fall. And my graph will look like that. So the major differences, again, are what I set my vertical asymptotes equal to and the direction. The left side will rise and the right will fall for the cotangent. Okay, so if I ask you to graph now y equals cotangent of 2x, you'd want to go through and identify your A, B, C, and D. So looking at this problem, my A value is what's out in front of the cotangent, which would be 1. My B value would be a 2. C value would be 0, and D would be 0 also. So if we list our formulas over here, and our bx minus c is equal to 0 and pi. So now we would say the amplitude would be 1, period would be pi over 1, which is just pi. Phase shift would be 0 because there is no c, and vertical shift would be 0. Now we'd have 2x equals 0. And 2x equals pi. So when I divide by 2, I get 0 and pi over 2 as my vertical asymptotes. So I keep a dashed line here at 0, go to pi over 2, and put a dashed line here as well. And I'm just realizing now, since my period here, this distance is pi over 2, but I wrote it as pi over here, that my b for this problem is 2. I guess I was thinking about the last one. And so my period is actually not going to be pi, it's going to be pi over 2. That's a good thing to kind of check, because this distance right here should be the same distance as your period when you set up your vertical asymptotes. What's nice about the cotangent and the tangent graph is that you don't have to calculate that. That's actually going to be figured out for you when you do the vertical asymptotes. Again, so that should be a pi over 2, not a pi. And so now if I think about the halfway point in between, between 0 and 1/2 would be 1/4, so it'd be pi over 4. And my cotangent graph, remember, left side rises, right side falls. And since my amplitude is 1, it's going to look something like that. It has a little bit of a curve to it. Putting on a next period, I would say, okay, let's add pi over 2, because that's the distance of my period. So if I take this part here, pi over 2, and I add pi over 2 to that, I end up with pi. Draw your vertical asymptotes. Halfway point between pi over 2, or between pi over 2 and pi would be 3 pi over 4. And then we left side rise, right side falls. And those would be the two periods for this graph. Okay, taking a look at this next graph, a couple things that stick out to me when I look at this graph is first of all, I've got a negative amplitude and I've got a cotangent here that's written as x over 3. So I'm just going to rewrite this first of all to say that it's y equals negative 1/2 cotangent of, in parentheses, 1/3 x. And I think by doing that, that's going to help me identify what my a, b, c, and d values are a lot easier. So I'm going to take the time to write out above here y equals a cotangent of bx minus c plus d, so I can figure out what the a, b, c, and d values are. So in this problem, a is going to be negative 1/2. And that's going to be important because that negative 1/2 is going to tell me that instead of it being a cotangent graph, it's going to be reflected, and my graph is actually going to look more like the tangent graph. So because I have a negative amplitude, my graph is going to rise to the right and fall to the left, so it would be something like this, not the cotangent graph. So keep that in mind when we go to plot it. Even though it's a cotangent graph, it has a negative amplitude, which means it's reflected. So my amplitude here, if I think about the absolute value of a, would be 1/2. My period, pi over b, would be, my b value is 1/3. By writing it like this, I think it's a lot easier to see the b versus x divided by 3. So this would be pi divided by 1/3. Well, pi divided by 1/3 is 3 pi. Phase shift, since my c value is 0, and my d value is 0, my phase shift, which is c over b, would be none, and my vertical shift, which is d, would be none also. So my vertical asymptotes would be bx minus c equal to 0 and equal to pi. In this case, my bx minus c is 1/3 x. So to solve this for x, I would multiply by 3, and I'd get 0. Multiply by 3 over here, I set it equal to 0, and that should be a pi. Sorry about that. Should be a pi from here. So when I multiply pi by 3, let me erase that, write that neater. When I times it by 3, I end up with 3 pi. So vertical asymptote at 0, vertical asymptote at 3 pi. Halfway point between 0 and 3 pi would be 1.5 pi, which is 3 pi over 2. And then remember that the negative amplitude here makes my graph really look like a tangent graph, where the right side is rising, the left side is falling. My 1/2 of the amplitude says that I have to hug the graph a little bit and then rise. hug the axis there a little bit, and then fall. So I'm going to have it be very curvy here because it's going to be compacted because of that 1/2. Let's put on another period. So I'd come over here, and I would think about this. If the period is 3 pi, I'm going to do this 3 pi plus 3 pi, which is going to get me to 6 pi as my next vertical asymptote. Halfway point between 3 pi and 6 pi would be 4.5 pi. As an improper fraction, that'd be 9 pi over 2. And then drawing this where it hugs the axis and then rises, hugs the axis and then falls, would look like that. Again, remember when you have problems where you have the negative amplitude, that is a reflection. And instead of it being the shape then of the cotangent graph, it really makes the tangent graph.